Welcome to School of Chemistry. In today's lesson, we'll be looking at coordinate covalent bond and examples of coordinate covalent bond. But first, let us look at the difference between covalent bond and coordinate covalent bond. Let us consider two business groups that need the basic of 10,000 to remain in business. In group 1, one member, we'll call him Mr. A, has 5,000. The other member, Mr. B, also has 5,000. So if they must remain in business, they have to contribute the 5,000 together so they can have a balance of 10,000. So in the world of chemistry, let's consider two atoms, A and B. Atom A with 1 electron and atom B with 1 electron. Let atom A donate its 1 electron in the first shell and atom B 1 electron, and they will form a covalent bond because the first shell will be satisfied, the duplex structure will be satisfied. So in covalent bonds, summarily, electrons are equally donated by both atoms. I repeat, in covalent bonds, electrons are equally donated by both atoms. Note that the shared electrons belongs to both atoms. The shared electron belongs to both atoms. In group 2, Mr. D, who is the husband, has 10,000, while the wife, I will call Mr. F, does not have anything, no income. So if they will remain in business, Mr. D will have to contribute all the money, so they will have a balance of 10,000. So, to be used by both of them. For instance, let's look at atom D and F. Atom D donates 2 electrons, while atom F doesn't donate any electrons. These electrons donated are shared between these two atoms to form a coordinate covalent bond. So, in coordinate covalent bond, a pair of electron, in coordinate covalent bond, a pair of electron is donated. A pair of electron is donated by one atom for both atoms to share. While in covalent bond, both atoms contribute to the shared pair equally. And this is the difference between covalent bond and coordinate covalent bond. Let's try to understand coordinate covalent bond. Let's consider an atom with a lone pair and an atom with an empty space. For example, let's consider nitrogen atom and hydrogen in the formation of ammonia. We know that nitrogen has 5 electrons in the outermost shell and it needs 3 more electrons to attain the octet structure. On the other hand, there's only 1 electron in the shell of hydrogen and it needs 1 more electron to attain its duplex structure. So, each hydrogen atom will share 1 electron each with nitrogen atom and they will form single covalent bonds. This shared pair is called bond pair. This is called a bond pair. This is called a bond pair. And this is called a lone pair because they do not participate in chemical bonds. So we have 3 covalent bonds and a lone pair, or 3 bond pair and a lone pair. Let's consider ammonia in an acid environment. That is ammonia in the presence of hydrogen ion. Now, the positive, remember that ammonia has lone pair. The positive charge on hydrogen means that it has lost 1 electron and the valence shell is completely empty and can accommodate 2 electrons. Now we'll have a lone pair of electrons from nitrogen, an empty space on the hydrogen ion. This lone pair of electrons from the nitrogen will be transferred to the hydrogen ion. To transfer, this lone pair now is being transferred to the what? Hydrogen ion. And coordinate covalent bond is formed and we get an ammonium ion. The lone pair donated is shared by nitrogen and the hydrogen ion, and the duplex structure of hydrogen is satisfied and the octet structure of hydrogen is what? Of nitrogen is satisfied. So this bond between hydrogen and nitrogen, there are 3 covalent bonds and 1 coordinate covalent bond. We write the structure with a positive charge, so we have 3 covalent bonds in ammonium ion and 1 coordinate covalent bond. Note, this is the structure for ammonium ion with the positive sign. The positive sign is for all the elements in the structure. Note, coordinate covalent bond is a covalent bond in which one atom donates the shared pair of electrons. I repeat, coordinate covalent bond is a covalent bond in which one atom donates the shared pair of electrons. Now, let's look at the formation of coordinate covalent bond in carbon monoxide. The formation of coordinate covalent bond in carbon monoxide. Consider carbon atom and oxygen. We know that in the valence share of carbon, there are 4 electrons. And in the valence share of oxygen, there are 6 electrons. Carbon and oxygen share 2 electrons each. If they contribute 2 electrons and share, they will form double covalent bond. If you count the number of electrons in the valence share of oxygen, you will get 8 electrons. The octet structure is satisfied. If you count that of carbon, you will get 6, and the octet structure is not attained, and it needs 2 more electrons in order to attain stability. Since oxygen has this lone pair, are you following? These are the 8 electrons. If you count, you see oxygen has 8 electrons, and carbon has 6 electrons. So carbon needs 2 more to be satisfied. And since oxygen has this lone pair and this lone pair, and carbon has this empty space, oxygen will transfer 1 lone pair of electron, and it will be shared between carbon and oxygen. So they will do the sharing. If oxygen transfer its lone pair to the shared pair, now we're going to have, instead of 2 shared pair, we're going to have 3 shared pair, out of which 1 is a lone pair. Now we have 8 electrons are present in the valence share of oxygen. If you count, this is the lone pair. This is the lone pair donated by oxygen. 8 electrons are present, and then we have 8 electrons also in the valence share of carbon. Hence, we write carbon monoxide like this. The structure of carbon monoxide, I'll write it with what? Triple bond. 1 double bond between carbon and we have 2 covalent bonds and 1 coordinate covalent bond. 2 covalent bonds and 1 coordinate covalent bond. If it's your first time in this channel, do not forget to subscribe, like, share, and comment. Thank you. You're welcome.